Hello students, we have been discussing about planetary model of atom which was proposed by Rutherford and modified by Bohr. So just a recap of what we have studied. Nucleus. An atom consists of a nucleus, a positively charged part which forms a tiny portion at the center, and electrons are revolving around in the circular orbits. So the only thing Bohr has considered is that not all the orbits are possible for electron to revolve around the nucleus. Some certain specified orbits which are called allowed orbits. So today we will see what is the radius of those permitted orbit and what will be the energy of the electron associated with those orbits. So for that, let us consider an atom with a nucleus which has a mass m, and there are z number of proton. A number of proton is designated as atomic number, and the charge of the nucleus will depend upon charge of the constituents. What are the constituents? Yes, proton and neutron. And is there any charge for proton? Yes, less E. And charge of neutron, they are neutral, and hence the name neutron. So the charge of the nucleus is given by charge of the proton. So we know that there are z number of protons in the nucleus, so the total charge will be z into E. Now we have an electron which revolves around the nucleus. Let it be of mass m, and we know the charge as negative E, and it is moving around the nucleus in an orbit of radius r. And let omega be the angular velocity of the electron. So r is the radius of, and this is the r. This r is what we are going to determine now. And compared to the mass of the electron, the mass of the nucleus is huge. So the nucleus is assumed to be stationary, and electron will be supposed to be rotating about the nucleus. So considering all these things, we can see that there is a negatively charged electron and positively charged nucleus. So what will be there? An attraction. What kind of attraction? Electrostatic attraction between the nucleus, positively charged, and the electron, which is negatively charged. And we have studied in our plus 2 and all, the electrostatic force is given by 1 by 4 pi epsilon 0. Charge of the first object, that is Ze in this case, and charge of the second one, Q2, which is given by E, charge of the electron, divided by square of the distance between those two charges. So this charge, this electrostatic force between the nucleus and the electron will give the necessary centripetal force to rotate about the nucleus or revolve around the nucleus, and the centripetal force is given by mv square by r. I think you would have experienced the centripetal force, that is, if you circulate a string with a stone at the other end, and if you circulate the string continuously, the stone will not fall down, right? It will be continuing the motion as such. But if you release it a bit, it will be flied off. Okay, so for a system to be stable, we require this attractive force to balance with the centripetal force. So that is what is written here. The centripetal force will be balanced by the electrostatic attraction to make the system stable, in the sense the electron to be revolving around the nucleus. All this. So from this we can deduce that m can be made to the other side, one of the r will cancel off, so remaining is v square is equal to 1 by 4 pi epsilon 0 z e square by r, other r is cancelled, and m from the left hand side. Okay. So let us consider that as the first equation. Now according to Bohr, he has mentioned that electron cannot vibrate in all the possible orbits. It can only rotate or occupy in those orbits whose angular momentum of the electron, in which the angular momentum of the electron will be integer multiple of h by 2 pi. So that we have already seen in its postulates for the atomic model. So considering that the angular momentum is expressed as mvr or m omega, which is same as mvr, it is given by nh by 2 pi as per the condition of Bohr. Now from this we have v as nh by 2 pi, m and r will come to the denominator. So we can substitute this equation into our first equation. So substituting that, we get nh by 2 pi rm all square is equal to 1 by 4 pi epsilon 0 z e square by rm. Okay, so rearranging that, you will be getting the answer for rm or expression for rm. Can you do it? So one of the m will cancel out, one of the r will cancel out, then 4, then 2 pi, 4 will cancel out, and one of the pi will cancel out. So remaining will be, can you do it? Just rearranging the and cancelling, you'll get it as, yes, r is equal to n square h square divided by n square h square, and r will be taken to this side. So 2 square is 4, which is cancelled. The remaining is 5. One of the pi is cancelled, pi square and pi I. Then r is taken to the right hand side. Then n square and m is there. So one of the m will cancel out. So finally what we have is n square h square divided by pi m, then z e square from this side, and epsilon 0 in the numerator. Okay, so this expression is very important, and this gives us the radius of nth permissible orbit. Okay, and what is your inference? H is the Planck's constant, epsilon is the permittivity of free space, and z is the atomic number, e is the charge of the electron, m is the mass of the electron. Although all these are constant. So here you can see that the radius of the orbit will vary with the orbit number as m square. Okay, so if you compare the ratio of all the radius, you can see that it will be increasing as the as 1 is to 4 is to 9 is to 6. That is, first orbit will be 1, second orbit is second, so 2 square, then third orbit is 3 square, fourth orbit is 4 square, and so on. So if you look at the orbits around the nucleus, the first orbit is shown here, the second orbit will be 4 times wider than the first one, and third orbit will be 9 times wider than the first one. Okay, so this orbits will be as we move away from the nucleus, the size of the orbit will be expanding. That is what is indicated from this expression. Okay, it is not a symmetric distribution, symmetric expansion, a symmetric way of concentric distribution. Rather, it has a expanding way, because we have square of integers. Okay, so which will give an expanded motion. Now let us come to the energy of electron in the allowed orbits or permitted orbits. So the total energy of the electron in an orbit is given by, as you know, it is just the sum of kinetic energy of the electron and potential energy of the electron in whichever orbit it is occupied. So kinetic energy, the expression is given by half mv square, while potential energy is given by electrostatic potential. So it is 1 by 4 pi epsilon 0. Ze is for nucleus into E is for electron divided by R. Potential, when it is potential, it is only R. When it is 4, it is R square. Okay, that is the difference. And one is positive nucleus and other is negative electron. So there will be a negative sign showing the attractive nature of the potential. So now you can substitute for V from our earlier equation, and V could be written as 1 by 4 pi epsilon 0 Z E square by R. So substituting that and rearranging, you will get it as the two similar terms. Okay, 1 by 8 pi epsilon 0 Z E square by R and 1 by 4 pi epsilon 0 Z E square by R. So which will give our expression as 1 by, which one is greater? Minus 1 by 4 is greater. So 1 by 8 minus 1 by 4 will be minus 1 by 8 pi epsilon 0 Z E square by R. Now we can substitute for the expression for radius of the orbit, which we have just derived it, which is n square h square epsilon 0 divided by pi Z E square m. So substituting that, can you substitute it and cancel it? So pi and pi cancel off, epsilon 0 becomes square, then n square is there, h square is there, then Z E square will come to the numerator, m will also come to the numerator. Okay. So let's write down the expression for energy. Did you reach at the expression? So what will be energy? Yes, it is minus 1 by 8 epsilon 0 square into Z square e raised to 4 m divided by n square h square. Okay, so this is the expression for energy of an electron occupying nth orbit. So here also you can see that Z is a constant, which is the atomic number of protons in a nucleus. E is the charge of the electron, m is the mass of the electron, h is Planck's constant. So everything else is constant except the number of the orbit. Okay. So what is the inference we can make it from the expression for energy? You can see that it is a negative nature and all of the others are constant except n. N will be varying with orbit. So here you can see that energy of electron occupying the nth orbit will be proportional to 1 by n square. Okay, and hence for a given n, En will be a constant, isn't it? En doesn't have any change, which means as long as the electron is in a particular orbit, it will not radiate energy. Isn't that the notion against what is proposed by Rutherford? That was a failure of Rutherford, right? Rutherford has considered that electron will be revolving in any of the orbit, and hence because it is a charged particle, it will be radiating out energy and it will be falling, collapsing into the nucleus. So that concept was disproved by Bohr by stating that En or energy just depends upon 1 by n square, and hence electron in a particular orbit will not radiate energy, it will be a constant. Only when if it changes the orbit or jumps from one orbit to another, there will be radiation of energy, extra energy or absorption. Okay, what is the other concept you can obtain from here? Anything else? So that is about, yeah, what about the value of energy for orbit, higher orbits and lower orbits? So here you can see that n square is appearing in the denominator, right? So as n increases, En will be decreasing. Amplitude, that is magnitude of energy will be increasing with decrease in n. Okay, or let me take it this way, as n increases for higher orbit, energy will be, the magnitude will be less, inversely proportional on the energy will be less. But here you can see that there is a negative sign also. Okay. So which one is higher? Is it -1 or -2 higher? it is -1. So negative value of a smaller quantity will be a high value than the other case. So the actual energy will increase with decrease in energy, which is due to the increase in n. Okay, so for higher orbit, energy will be larger, though its magnitude is less due to the presence of negative sign. It will have a higher energy than the inner orbit. And what does the negative sign indicate? That we have already mentioned. It is due to the attractive nature of the nucleus. That is, electron is bound to the nucleus by the attractive forces. So that we must supply some energy to separate the electron from the nucleus. Okay. So these are the points about inferences we have derived from the expression for energy. So it could be asked as an essay also, that is describe Bohr's atomic model and obtain the expression for radii and energy for the permitted orbit. Okay, so you can submit as in your lecture note itself. You can write down all these points and submit as an assignment. Okay, thank you.